So, I don't know when last I spoke to this group about our efforts in informal science education. And this will be informal in itself, the presentation, although I've got plenty of results. So I want to tell you a little bit about why I engage in informal science education, or why we involve in science education, what we do in our programs, why it is a research activity, the kinds of research that we do, and really sort of push the envelope on what kinds of research we would want to do as a research enterprise. This is really a collaborative project. Laurel Mayhew is certainly co-author on this, and Colin has been instrumental, Colin here, and doing his senior thesis with us on this project, and probably knows the ins and outs of what actually happens better than I do. I'm really good at 30,000 feet, and Colin's better at about 6 feet. So stop and ask questions along the way. By way of being explicit about this, since this seems to come up in a variety of different venues, why is it that faculty do things, what is the nature of the university, and what is it that we're about? I started my research in physics education in informal science. So when I transitioned into PER, I was doing after-school programs for a bunch of reasons that I'll get to. When I came here, I very explicitly did not. Not because I lost interest in it, not because I thought it was unimportant, but because it was politically sensitive. Here's one of the real strengths of tenure. Now you get to do what you want. And in fact, I think this is what tenure is designed for in a particular way. So, for better or worse, I think that thinking about informal science education the way we do is unusual. And to think about that as a scholarly pursuit, as a research activity in a physics department is near unheard of. So if you think about it, where is it? Let's just start to sort of unpack this a little bit. We have matzo too. Some Easter eggs that came from the chocolate bunny. Where did PER start, and why did it take off, and why does it exist in physics departments? It's not a trick question. Where has most of the work been done?
Aaron's UW.
Yeah, Aaron's. And what was he focusing on? What level was he focusing on? What was he doing?
Wasn't it introductory physics misconceptions?
Yeah, introductory physics and misconceptions. Large-scale classes. Everybody recognizes this is what we do and how we spend our time.
Hey!
Welcome back, Valerie. Top of the morning to you.
Top of the morning.
Freshly back from Ireland.
Oh, really?
So right, I think PER started there, and there's been relatively little work in physics departments on pre-college education. And when that's happened, it's happened in the formal system, in the formal school system. When so that said, the reason I went to go work and do PER in after school and informal, one of the reasons was I had far greater access. You go to an environment that nobody pays attention to, then you can do whatever you want. It's sort of like transforming physics for non-science majors. But try and change the E&M class, and it's a little bit more politically sensitive. Maybe. We'll see. Anyway, this is maybe another reason why introductory, PER was allowed to work in introductory. Maybe. Let's see. So this project, it's not a small project that we're involved in. We've been overlapping and increasingly trying to sort of partner with CU Teach. It's a natural partner with that, and certainly the LA program should add here. We've had funding from National Science Foundation, JILA in particular. We've had 2 Diversity and Excellence Awards for this effort. The LA program and the Department of Physics have all contributed to this. So why work in informal science education? Arguably, it's our mission. Now, I know most people don't pay attention to, or they may not be aware of this, our charter mission as a state-chartered institution. But we're here to serve the people of Colorado. And we do that through research, teaching, and service, which is interesting. And I'm actually quite proud of this institution in thinking about this. It's got a long ways to go. Colorado's not known as being the most engaged institution in the community, but it's working on it. And there's a new Vice Chancellor of Outreach, Ann Hines, who chaired this commission to redefine outreach and engagement. I don't use the term outreach, you'll see here, but I just emphasize a couple of things here to talk about beneficial partnerships. I talk about community partnerships, and you'll see here this language has appeared in the working document, which is great. Outreach is not this delivery of information. We're not here handing out soup to kids, right? Although feeding people is a good thing to do. But our model is more about benefiting from this interaction ourselves, seeing this as part of our core identity and core mission here, through the reciprocal nature of outreach. So I think the term outreach is loaded, which is why I don't use it, but in our redefinition of outreach, we've included both the denotation and connotation that I would like. Questions about that? So what is the need in pre-college? I mean, so how are we doing in our educational system before college?
What was last word?
How well are we doing in our pre-college education system?
Shitty.
Yeah,
Come on, we rock.
we rock.
I just can't understand it. You want me to go on?
Yeah. So you could say that the demographics in physics, I mean, relatively few people, the number of students going into physics is increasing. Let's say you were concerned about the number of students in high school who are taking physics. And you're most likely to take physics. 47% of Asians are now taking physics in high school. But still, you see there's a huge gap here. 2001, 33%. I'm sure these numbers continue to increase. Probably not for blacks and Hispanics, though. We're 1 in 5. And these are somewhat old data, but I'll update them a little bit too here. If you were a kid in kindergarten, the likelihood here that you obtain at least a bachelor's degree is a whopping 50%, the national average here. Right. 30% Anglo here. Most people graduate from high school. Now this is a sample study here, and we actually have broader demographics that I'll bring up in a minute, but this also talks about the problem is actually not graduating from high school necessarily, although that's important, and maybe not even getting into college. Huge fraction actually obtain some college here, but they don't go and complete college. The argument that I have here is that we're preparing students to get into college, but not to be in college. Mostly this is at the 2-year college level. 2005 report cards, although it's the same here, is that there's a huge performance gap. Here's arbitrary performance, higher is better here, over 96 to 2005 here. And we see a significant performance gap.
Noah,
Yep.
there was an article in the paper today that was arguing that it's not that we're not preparing our students to be in college, it's that they can't afford to stay in college. So the reason for those high dropout rates from college is not necessarily one or exclusively one of academic preparation, but of the cost of university now.
Oh, I think that's a great question. It's definitely worth looking into. I wouldn't necessarily separate those two, to be honest. I think they're related. But the point is, you know, if you're working 2 jobs in order to pay for college, how are you going to perform well in college, right? So I think these are absolutely coupled.
Right, but you're making this the case that the issue is poor academic preparation.
Oh, I didn't necessarily say that. I mean, I think they are coupled, and I think that there are. But I think I would actually argue preparation in general. We're preparing people to be in college, but not to be in college, which is now there are new demands on people. Not only are there academic and intellectual demands, but there are then financial demands on people that we shouldn't have.
Yeah, but you can separate them, and you can separate them, and you can say if we prepare people exactly the same all the way from would be a totally different picture, and then it wouldn't be a matter of academic preparation. It
Oh,
would be a matter of the constraints once you get into college. So, I mean, separation does something important.
I think it's possible that we can disaggregate some of it. I still think that they're coupled, which is to say, if you're under financial pressure, that's going to have academic outcomes and problems for you. The question is that doesn't tell you that it drives it the other way, which is to say you just want to teach people to do better or cope better while having two jobs. So I think you're absolutely right. And this is a relatively new phenomenon, whereas the college graduation rate is not. So I mean, I think both issues are going on, and it's going to be both of these things for sure. And it's only going to get worse financially, that's for sure. At least the expectations here. And a lot of these issues overlap directly with socioeconomic status as well. But what I would argue is then, if these are issues of social class, and predominantly it's Hispanics and blacks, Africans Americans, Native Americans who are underrepresented and disproportionately represented in low SES, social economic status, then in fact that is not only a class issue but a race issue.
Question.
Yep.
Those data that you just showed,
Yep.
do you have trends over time?
There are trends over time.
What do you mean?
I can, you know.
These go back, 8th grade NAEP data go back to the 60s, I believe.
Okay.
And some NAEP data go back earlier than that. And there hasn't been a huge shift, interestingly enough, except the argument is that we are closing this race gap, but it's with Anglo performance decreasing. Colorado's a little bit better off, actually. These are the National Assessment of Educational Progress. The number of folks who are at or below basic. Basic is such an unbelievably low bar on this that I use proficient as my standard here, which is proficient and above. And, you know, either way, above basic here is a third or less of students in Colorado, and the trend is not moving in the right direction. Over time, we are better off nationally. 2 out of 3 8th graders are not proficient in science, I guess. That's the point. I take home for that. Here are some graduation rates from 2000 to 2010 that I just pulled off. These are high school graduation rates by ethnicity for the state of Colorado. And we're at about 73%, which is high by the nation, but going down. And again, you'll see some disturbing trends here by ethnicity and trajectory here. Interestingly enough, so there's a significant racial gap by high school graduation. There's this interesting website that I just found today, interestingly enough, from Change the Equation, which if you want some of these data and want to look at some of this, Change the Equation is a sort of national nonprofit that was recently formed by industry, or a coalition of industry CEOs. But this is a kind of interesting statistic here. So you can just sort of go over which state you want. So Colorado, 24% below basic, 40% above basic in 8th grade math. 73% graduate from high school 4 years. 1/3 of 8th graders write about science, do science reports. Or you could just click on this and it'll pull up a whole PDF with other kinds of vital science, academic expectations, state teacher preparation. Here's an interesting statistic. Where does Colorado set the passing score for elementary teacher content licensure? And the answer is in the 16th percentile of the national average.
For elementary teachers?
So in order to,
16th percentile for the national average for expectations for elementary teachers?
16th percentile of performance, I believe, is what this is. Although we should dig this out. This is an actual National Council on Teacher Quality, which we have some issues with, of course.
Wait. So this may.
We just set a low bar.
Not so obvious. I mean, when you have a Gaussian distribution of grades,
Yeah.
typically 15% fail, and that's exactly what this is saying. I mean, that's just the canonical, 90 to 100 is an A, 80 to 90 is. I mean, it's
Oh, this is well below the average score for all test takers.
Right.
Yeah. Well, we can talk about it. I mean, so anyway, here are some of the data. These actually get to be fuzzy issues. There's some interesting survey data here on how often do things happen in your 4th and 8th grade classes. Well, do you ever get to do a science experiment? Never or hardly ever is only, it's 1/3, 28%, sorry, closer to a quarter. So they get to do something. Maybe that's a function of FOSS kits, which is nice.
Can you just, if you don't want to, if you want to just move on, go ahead.
Yeah.
Who compiled this website? What is this?
This website is from Change the Equation, which is relatively new nonprofit. I mean, there are major initiatives that are going on. This happens to be CEOs from industry,
Right.
and they are a major player in the Educate to Innovate campaign from the White House. Okay, anyway, so I think there's significant evidence that we're not doing what we want to do, maybe. I'm certainly not over the top. We need, these are areas of national teacher demands. 2007 hasn't changed. Highest areas and the highest rankings are in math and physics here for teachers, so that's why we couple with this. The National Academies Reports has written about this. I mean, there's plenty of information in learning in informal environments. Commission reports that we looked at. They have a variety of strands of focus to focus on excitement, interest, generate enthusiasm. These are what they say is important for informal science. Not surprisingly, I think that this is what's important for science. Albeit they claim that strands 1 and 6 are particularly important in informal environments, that school doesn't have to engage people with excitement and interest and motivate, because they're already there maybe, I don't know. These are sort of scientific practices here, as opposed to identity and interest are. That's a differential purview. I don't know if that's true. We'll see if this trend continues, but No Child Left Behind actually took informal education out. Well, took science out of the school time. Yeah?
Well, I had one question about the strands on the
Sure.
previous slide. So, like, when they talk about, like, science learners who develop an identity and all these things, like, are they thinking, like, kids, or are they thinking people of all age levels?
Oh, predominantly kids. Yeah.
Okay.
Yeah. But they do talk about public engagement, but this report particularly is emphasizing kids. Anyway, not to dwell on it, but there's an argument that No Child Left Behind has actually reduced the amount of time on task in classrooms for doing science because it wasn't tested. This came up in our political discussion the other day. Should we have annual yearly progress? So if you test it, then they'll be forced to do it. And, well, so this does leave an opportunity here for informal opportunities. So for students to engage in informal environments. There's a nice piece by Schwartz and Noam, if you want. It's part of the commission papers on this. Some recommendation that comes out of this is we should follow principles of learning. We should build community education partnerships, things that are consequential and relevant to community members. Educational tools and materials development is really important, as well as actively supporting and developing the capacity of educators within these environments. All very reasonable and important sort of goals, and very nicely aligned with what we find in other areas of the formal school system and informal science. Just briefly here, sorry I should have animated this, there are various types of informal. I will not be talking about museum visits, video or movies, or field trips. These are generally one-shot deals. These are generally what get funded, interestingly enough. If you look at the NSF Informal Science Education strand, they'll fund things like NOVA. Reaches millions of people, but once. Sort of an interesting sort of framing on it. There's the repeated, which is after school, summer programs, or clubs. And they serve different roles. You can think about different numbers of students, different objectives that are underway here, and a different way of thinking about the delivery of content. Either way, there's relatively little research on the impact of these environments. So, do you want more? Well, I'll go very briefly through this here. If we consider informal science in the after-school. Museum science is learner-directed and hands-on. And it's been argued that we can build on this idea of museum science and after-school youth programs. There's a huge after-school youth program, and there's a big museum science program. Why don't we bring those two ideas together? Because after-school youth programs have focused on hands-on activity with peers, but no science content. All right? Think Boy Scouts. Although I haven't been to Boy Scouts recently, but it's been directed at confidence and self-expression, which are good, but why not do that around science content? So this is, in fact, what we want to see here is focusing on the after-school and informal science as an opportunity to triangulate among school system, other informal environments, community centers, and even the home and family. We find parental involvement to be tremendously important. And actually, also, it's a potential to serve as a mediating element between the legs of these different components, so that you can actually use this. Hopefully, you can imagine after school to remediate home support in the formal school system, to engage parents in there. So that's some of the backdrop about why we're doing and some of the framing about what we would get to. So we have this partnerships in informal science education in the community that Laurel and I started here. And we have 3 different kinds of objectives for this. We're looking to support the university end of things. How is it that the university would benefit? We're interested in the retention and development of students, the recruitment of teachers and majors, and the improvement of education for universities. So these are what we consider direct benefits to the university students or population here. For the children participating, we see this as an opportunity for improving their interest and acuity in STEM, the development of teachers and community leaders, and the improvement of education that's offered in these informal environments. And then finally, on the third leg of this is we're really interested in thinking about creating sustainable systems. This is on an institutional level to create sustainable systems for the communities and the universities. I'd also add research as an opportunity here, that the university identity around research in this place is a component. So, wow. Sorry about the colors. So we talk about university community partnerships. This is our version of outreach. So we have university educators here that are at CU. Ian's gone out and worked with kids. Colin has at local community centers or in school in the after-school settings here, and they come to create a jointly constructed environment. The Junior Scientist League is what we used to call it, where kids engage in playful activities like moving man and computer simulation to make sense of environments that they embed themselves in, or make movies using stop-action motion to make sense of what's happening. And from the kids' perspective, these activities, and we use a modified version of Valerie's curriculum, the physics and everyday thinking, or physical science and everyday thinking, so that we don't have to reinvent the wheel here. The kids see this as voluntary. Now, it's actually interesting from the kids' perspective. Kids don't get a lot of choice in the world, but it's not a required part of them. They get to choose. If they either have to stay after school or they don't, or they go to early release or they don't. But that said, they don't have to participate in these particular programs for their other alternatives. It's play-based. We really build on this idea to say, wait a sec, we want to say you are in an engaging, playful environment. We focus on repeated interactions to help have sustained connection to the material and the content and the people who are involved in this. Strong emphasis in science, and we really like to make this student-driven, both the undergraduate side and community side. Why don't I turn it over to you, Colin, briefly to just sort of walk through and describe a little bit more about what happens in practice at sites, and then I'll turn to what it is that we're collecting data and research on.
Okay.
All right?
So, my involvement with PySec this semester has been towards developing this binder that basically has everything you need to run the program. So, starting with basically a simple background of what we do and why we focus on partnership as opposed to outreach. And also focusing on trainings. We have to train all of the university participants that we bring onto site with us. That turns out to be a really big part of the program. and training time is almost about equal to the amount of time at site. So it's sort of a big issue. So what happens when we go to site, I go to this place called Heritage Middle School out in Longmont, and I'm one of the fellows, which means that I lead the environment there, and I'm responsible for transporting the other university educators there. And we always form groups when we get there, and it's typical that the same kids work with the same university educators week in and week out, and they develop relationships that way. And so what we do is, as far as research goes,
Well, hold up on the research. So just walk people through what it is that you do. So the kids show up, they partner with some university students,
right,
and then what do they do?
then we jump into the game, and we do something physical, like we all jump up and say that we teleport, or we parachute into a jungle, or something like that to change change the setting for them. And it really does get them out of thinking that they're in school and they're in a more playful environment. You can see the shift almost immediately.
It's like people are jumping into World of Warcraft, except that we're still physically present in some place, but we're jumping into a metaphorical space, a cave or a jungle.
Exactly.
And the environments are all tied to the activity. I know we're all talking about making a circuit to light up a cave so you can see.
Yes. So we have the two curriculums I'm familiar with, which I think are the two main ones we've been using. One is electricity, a circuits curriculum, where you find yourself in a cave and it's dark, but you have a battery and a wire and a light bulb. So the idea is you build your own flashlight in order to navigate around these caves. And this semester, the curriculum we've been working on is one that we call, instead of being caves, it's mazes. So the idea is that there's these mazes in the jungle that the kids parachute into from a plane that's flying overhead, and you have to find your way out of the maze, eventually facing various challenges and things like that. And the cave is similar, but you're in a cave as opposed to a maze. That's pretty much it.
And so the curriculum the kids work through is actually some of the materials from the PET curriculum combined with the stop-action motion video and the PET computer simulations. We have run robotics and are not currently in there. And it's really based on this idea of student construction of activities, of partnership, and this idea of play, embedding yourself in sort of this larger world, what some would call a tertiary artifact, or a larger cultural system, a micro world in which we embed ourselves.
Do you guys bring all the supplies to the site, or what do you take advantage that they already have?
We take advantage of the kids that they have, the time, the teacher who has to be there to supervise the kids, and the desks and pencils, perhaps, which is about all the material that they have. But it depends on the site. Sometimes they have computer labs, but we bring our own computers down because there are computer labs and there are computer labs. I guess that's my answer. And it's a pain, right? So the classrooms are not wired in ways that you want them to be. So we produce all of that.
Are there specific communities that you target?
Yeah, so we target historically underrepresented minorities. In this area, it's dominantly Hispanic. Nearly all of our kids are on free and reduced lunch. In the programs, we target age-wise late elementary and middle. We have worked in high school and we have worked earlier there. So, right. And this is, again, good for everybody sort of involved, but it does have this intention to support those who haven't had as much support as majority populations.
When you say student-driven, what do you mean by that? Like the activities you're describing sound like sort of kind of activities I think of, which I don't tend to think are student-driven. You know?
Right, so it's a varying degree, and that's an area that we really are working on. So the pace at which kids work is up to them. They don't have to finish at any particular time. We try to provide incentive along the ways. There are choices and branches within these mazes about different kinds of activities that people can participate in along the way, so we try to provide some of that. Ultimately, we're trying to build a structure for kids who have been in the system long enough. This is built on another program, the Fifth Dimension, that I was involved in San Diego. In fact, I was a kid in that program back in the day, and it was developed by my postdoc advisor. Like to mimic one of their other elements, which is people who are in this environment that is also run by a wizard, which has all kinds of interesting pedagogical and psychological impacts in a positive way, which we try and employ. You can get into that if you're interested. But we have these young wizard assistants. If you've been around for a while, you take greater ownership for what gets happening. So you get to write and design kinds of materials and activities that happen for other kids to participate in these environments. So ultimately, it's an environment that we really want to co-construct with the kids. We're a little bit heavy-handed with it right now in terms of the direction of what the content is that people learn. That said, how they get to express that, the pace at which they go in, and often the order they get to go is theirs.
And it's not clear to me what the sweet spot of student-driven is at various times within the experience for the student. It's like not clear.
Right.
What, you know, we still, we meaning people who try to do this stuff, are still looking for, you know, what is the sweet spot with regards to that.
Right. You don't want to ask a bunch of fourth graders, hey, do you want to do physics now?
Go do physics. Go design a mousetrap, you know, launcher or whatever it is. You know.
Right, yeah. And the other thing is, right, I mean, the point is we want to, the model that we take actually is one of enculturation, of people participating more and more within the system, and then the more they do, the more they understand and take ownership for that culture, like what it is to do science, and they get to direct then what it is. So, yeah, great question. And something we're working on. This is far from a polished system. I'll also say, so Chris Gutierrez, who's here, has built one of these, and she's like a masterful architect of these kinds of environments and has a course in School of Ed that does this. She spent roughly a full year sort of designing her environment, partnering with local community, engaging in discussions and whatnot. We went out and started 6 sites our first semester. Right? We have a very different approach. And hers is much more likely to be sustained and positively impact kids. Ours, we're learning a lot and may also positively impact kids. We can talk about the design of institutional structures. In fact, we will a little bit. From the research side, we're really looking at the impact on the university side. We want the university to say, hey, this is an experiential learning program, part of the flagship 2030 initiatives. This is a great way for students to learn content. We're also interested in, for undergrads and grads to learn content. There's a big move at the National Science Foundation now on communication about science in everyday language. We can demonstrate that by participating in these activities, the graduate students in GILA are better able to communicate about their research projects in ways that are accessible. We're interested in the impact on children and the impact on the institutions. We're interested in why and how these impact these elements. And then also on tools development. So one project has been the communication everyday language. The other has been a modification of the class, which is now the CAS, the Children's Attitudes About Science, survey. So we've been running for 4 or 5 years. It depends on how you count. We've run at least 5 elementary schools and 2 middle schools, 1 high school and 3 after school on our community-based sites. Some of these community-based sites, we go to the homes where kids live and get to play scientifically. That says, wait a sec, this isn't something that only happens in school. Each semester, I should also mention that all the kids come and show their movies that they've made down in G1B20 as part of a field trip where they take ownership of the college space and present to all the rest of the kids, as well as do lab tours to see, one of the fastest things in the universe and the coldest spot in the universe. We've hit 18 unique teachers, 67 teacher semesters here, 157 UEs, mostly unique UEs are university educators here. So we sort of impact a number of folks. We've been collecting data on positive impact here, content mastery here. It's happened to be a summer camp in 2006, but we saw through repeated exposure, students developed a more sophisticated view about models of solid, liquid, and gas. We do continue to collect data on this positively impacting content knowledge. We also see that we've been looking at the beliefs about science. You may have seen this before, pre and post data, shifting towards more favorable from blue to yellow generally on these, albeit they may shift to more favorable views about science. They may not. It may happen over the course of time over the scale of semesters. This happens to be an open research question. Certainly they don't get worse, and we really need to track this over time. Lots of evidence that we have that this positively impacts university student identity engagement. This was from an REU student that we had. For 4 days I had about as much fun as I've ever had doing anything. This was definitely one of the best experiences of my life, referring to teaching a summer camp to at-risk youth as part of the I Have a Dream Foundation here. Another student that same semester is going on to become a teacher. The summer camp was the most valuable experience I've had as a future secondary science teacher. This is an invaluable opportunity that should be extended to all prospective science students. The point is that these students get to go and help design and create the educational structures there, rather than assume everything from an institutional structure and be given a playbook about how to participate. Yeah.
So the EQ was talking about secondary science teachers and the secondary. So was that in a secondary science setting?
That was a middle school program
Middle school
that we ran.
Yeah, I mean,
I think the reason that EQ was talking about this was that science certification is for secondary. When you get certified as a science teacher, it only happens in that secondary level as opposed to primary.
Okay. And does the program target secondary teachers more than potential secondary teachers?
The UEs, the university educators that we target, are those who may possibly have some interest in it. We love having LAs or former LAs participating, but we also get many graduate students from the PFC, the Physics Frontier Center. This is where the funding for this project dominantly comes from right now, is they're required to have an educational component for this, atomic, molecular, optical, the ultra-cooled atom center here. So we see this as part of the education, and the PFC sees this as part of the education of their graduate students, that they get exposure to what does it mean to educate, and what does it mean to work with at-risk youth, and what does it mean to communicate about science to this environment. So we target anybody who has a potential. I think this goes back to my phrase statement that I think everybody's an educator, some more formal than others.
Yeah. Did you go after the potential middle school teachers?
Yeah, we don't have a separate middle school certification here or middle school program here. But it would be great to have some of our secondary licensure choose to go into middle school because they had a positive experience in these environments. So I think it's a ripe opportunity that we haven't taken advantage of yet here. So they identify more strongly as educators. These are old data here, but these are pre-post tests on content mastery. This happens to be the CSEM that I gave to non-majors and majors, and in fact a J over our graduate students here in physics on the CSEM pre-post tests. Really remarkable. I mean, take a graduate student scoring less than 50 on the CSEM. It's, you learn physics as a result of this.
Those are the pre-post before and after the experience?
Yes, it's coupled with the training and courses on that. So
These were students from your teaching and learning physics class.
Students in the teaching and learning physics class, but they were all going to an informal science program.
But
teaching
they
the
were
content.
also in a teaching and learning physics class, which this group is not.
Correct. Right. Although they do have substantial training on the content, which we can talk about, but it is not a formal course. You're right. So I don't even know if we collect. I don't think we'd have pre-post data on the UEs on the content. No. Might be an interesting thing for us to sort of collect. It'd be an interesting examination. We do have on some of the teachers pre-post data on the teachers in these environments, and the teachers' mastery of the content is about as paltry as the children's, especially in the elementary schools. Pre. People talk about teaching differently as a result of this. They move from this idea about repetition, for example, here to leading through interactive experiences. We not only explicitly talk about this in our teaching practices, but also in our training practices, but model that and have people experience in that. We've had a variety of undergraduate research efforts with this, at least 4 different senior or honors theses about these, many of which have resulted in PERT papers and ought to result in other theses. So it's a sort of areas here. So there are some open questions here in the end that we should have partnerships with other programs. FET we have, already we use the materials, but now FET's got this middle school program. It'd be a nice opportunity to think about informal versus formal middle school use of this. CU Teach, we did have one pilot semester of running a step 1 class that was for informal science education. I would love to do that again. This is to send students out to the field through supported. Right now, PISIC is voluntary participation for university educators, and we still get it fully staffed every semester. But why not build this into the institutional framework? Why not use this as an explicit recruiting tool? And there are some reasons why not to. So for instance, we don't teach the 5 E's.
Well, I mean, now that the CU Teach program is in its last year of funding and we no longer have to follow the mothership, we will start to see the way that we can take everything we've learned from CU Teach and incorporate a greater variety of unique ideas into that program. And that's when I think we'll really start to see not just this integration, but new ideas about how informal and formal science education are
Linked. Right. So, I mean, just and follow up on this, I mean, we have this artificial divide between formal and informal. One activist agenda that we have is to seed change in the formal school system by working with teachers in the after school. And they're like, oh, hey, cool, I can use FET. I never knew about that. I'm going to bring that into my classroom. Or I really should pay attention to what students are thinking before I simply, direct a lesson. Or this works so well with this activity works so well with the after school kids, like movie making. I'm going to try it in my formal classroom setting. This would really help me in my activities. And maybe even the teachers learn something along the way. I think this is something that could expand and really, I should have the outreach and continuing studies here, same offices. I think this is a great opportunity to join efforts here on professional development as well. Science discovery, new director there, plenty of potential. LASP has a big outreach effort this we've been talking with. But then also, we know how to study the impact on UEs. We've done some and not done others. And on children, we have less of a foothold on how to study institutional impact. Like, can programs like this shift the identity of the institution? Can this become a course? And is that a shift in, does the university really start saying, aha, this is what we do? And let me give a spin for this. If I want my students to go and do research on children's learning, I can set up a lab and ask for $1.5 million, like Rashke got for his laser lab or whatever it happened to be, and create an environment where I pay kids to come in and play around with very controlled items, or I can go work with Casa de la Esperanza and look at kids learning in situ, where they provide us the lab that our kids go and participate in, right? And study student learning in situ. That's one way of reframing what it is the nature of this kind of research and educational transformation is about, is that the university is getting a huge boon by being able to participate and fulfilling its charter commitment. So I don't know if you have ideas particularly on this. So let me come back to these sort of open questions along the way. By way of summary, of course, we have to think our relationships between university and community programs. I think the university is on the right trajectory. It's possible to create partnerships where everybody benefits. We believe that we can have sustainable programs that don't require huge amounts of external money from one-time pots. And we can reshift the identity of all participants, the children, the university educators, the fellows, and maybe even the institutions themselves. There's a flexible model where the content and the participants themselves are modular, which is to say you could scale this kind of partnership activity to different audiences and different content. And what I like about this is this doesn't throw out the structure of the existing systems. This doesn't throw out the formal school system. This doesn't throw out after-school or club-based programming, but rather it gives us an opportunity for critical reform within those structures, which is much more the model that we have along the way. So I think it has significant potential along the way. And of course, on something like this that's activist, I always like to end with Charles' framing.
No, what does PISEC cost?
What does PISEC cost?
Is there a dollar?
Yes, there is a dollar amount. So, I mean, it depends on what you mean. So, PISEC is probably half, I would say, or more. I mean, it depends on if you include the research side as part of PISEC. But it's between a half and a full-time postdoc, right? So, Laurel's duties, she does, more than just PISEC. But half or two-thirds of a postdoc salary. We have one fellow per site, which is on the order of actually half an LA. So that's, then I would say 3,000, 6,000 a year for, say, 4 sites. It depends on how many we want to scale to along the way. But if we were to run, say, at 4 sites, which is our current model, I would say explicit costs then are, let's say $30,000 for a director, and $6,000 for fellows, $10,000 for fellows, let's say, 40,000, so 10,000 a site per year, for a year. And that's with voluntary participation, but, the nice thing about it is that scales very easily. One director could supervise 6 or 8 fellows, especially with Colin's new manual, there, and if we built it in with a class, we could have, 20 or 40 undergraduate educators or university educators going out to work for the fellows. There's material supplies. We probably spend about $500 a year on material supplies, and then there's food for the trainings that we offer for the volunteers along the way. So it's another like $1,500 maybe, but so not a lot. I mean, something. It's really
Under $50,000 a year.
yes. I mean, we wrote. It depends on who we're asking for money. We asked NSF for $1.5 million to scale out to 20 sites. We weren't funded, but with $5,000 from the outreach fund and Laurel's salary, we've been able to run that easily for a year.
But it seems to me that we could eventually, as we continue as a university to rethink what teacher preparation needs and what education needs, that we would have the director of field placements, which is a part of the budget, is placing students in field placements, which include formal and informal places.
Yep.
And that is the director's salary, or maybe there are 2 of them, but that's a part of what we do as a unit.
Right.
And that goes to your description of what kinds of impact does it have on the university.
And if this is a class that's offered that's tuition generating, such as step 1,
Or a part of the teacher prep program. You
Right.
have to have your informal science experience. I mean, I can't even imagine why we're putting teachers out there without having them have that informal science education experience in order to help them generate a better model of what it means to be a teacher.
right?
Of not just the students, but the community with whom they're dealing and the parents who they're going to deal with. You're dealing with parents whether you like it or not. It sure be nice to have the opportunity to do it.
Right. And to recognize the kids not as units that walk into the classroom, but as humans that have these rich life experiences.
Absolutely.
And, so one of the nice things about working at CASA, for instance, is that we go down and we provide science, right, and opportunities to engage that, and the parents bring food. Well, what a great way to learn, build community. And I get to have some good food along the way, the kids are hungry, and I'm participating. If I have discipline issues, I bring it up with their parents. There's nobody better, anyway, suited to make sure that the kids, respect what's going on there. So, yeah.
I have another question, if nobody else does. I can imagine, I've been thinking for years about how an informal science program, or even a formal science program, could provide opportunities for parents potentially first-gen students, to, if you will, run the program so that our education, some of what we provide would be for the parents to take over some level of ownership of the program, and that would fold them into kind of the science system that they may already currently feel alienated from. It seems like that would be a really perfect opportunity for this kind of effort, since we're already bringing food,
Right. So the idea over here is that the university provides a fellow who the UEs, university educators, to come and participate in some of the materials. The community center after school brings an education professional of some sort. After school, we're not allowed to work unless the teacher's there. This is part of one partner that we didn't talk about behind this is MESA, Math, Engineering, Science Achievement, big statewide organization, national organization, but the statewide MESA. They love us. They asked us to roll out to 20 sites along the way. The teachers are clamoring to have support for materials that they run as part of MESA, and we should make that part of their professional development. And yes, we should have parents involved as part of the leads over here. They know the kids, they know the environment, they know the local context. I don't know snot about kids' snot. Right? But these teachers do. They're like, oh, Johnny's just sick today, right? Don't worry about it. So, that's, sort of a wealth of absolutely critical information or expertise that we don't have, that our UEs learn sort of in partnership with the teachers along the way. And so that's what it's meant to be, sort of a joint program that way. And so I think, again, rich opportunity to leverage structures. So, thank you. So let me just ask, and then I'll let you guys go. And how do I study the institutional impact without getting, huge amount of money for ethnographers?
Well, with noise fellows for one thing.
What do we track institutionally?
I don't understand your question. You're saying what are you tracking at the schools where you're doing the ISE, or what are you tracking institutionally?
I want to study. So we believe that children are transformed by participating in this. University students are transformed. People are transformed. But we also believe that the institutions themselves may be transformed. So what the University of Colorado is and what it does, what Casa de la Esperanza is and what it does, what Spangler Elementary or Heritage Middle is and does changes.
It's one of the things you could look at. It's harder to do at the middle school than it is at the high school, but look at enrollment. Does the enrollment in science courses change? Does it go up?
Oh, interesting. Do they become more popular? And does that bleed over into the formal?
Another obvious thing to study is kind of it's like the LA program, right? This is like the community component of the LA program, because that's all I can do. Is the impact on the uni, the impact on the uni, and how this is becoming a critical component of their education. How do they compare to similar students with the same majors who are now finishing their degree as far as the substance of their experience? And I don't know, maybe it's a survey. What was your experience? And we could do that with LAs also, and we do that with LAs at some level, not a good enough level, but kind of like what role did this play in your education at CU Boulder?
Right.
And that's just the undergrads, impact on undergrads, the undergraduate education at CU.
And you can do a similar survey for the teachers that are.
Right. Has this shifted your practice in the classroom? Has it shifted how you think about what you're doing? It's a good idea.
Do you have a hypothesis about what the changes are?
Good question.
What the institutional changes are?
Yeah, I mean, at the institutional level, I wanted to see become part of, I guess I want to see two things. I want to see these kinds of activities fulfilling missions that we already have as an institution. So if we're supposed to teach undergraduates physics or develop their communication skills or whatever, this is one of the sets of opportunities that the institution offers. So that's one way to see it. But I also want to see it, and maybe I've already sort of tipped my hand on it, I also want to see it shift the nature of what the institution itself values. So it says, aha, it's not just content mastery of basic E&M, but it's communication skills. It's an awareness about the community and a commitment to engage in the community. And so that would be those, I don't know if those are hypotheses, those would be desires.
Right, so the second one, I guess you could survey people about what they think are the important things.
Yeah, what are the roles?
For,
Right.
you know, you could even do multiple choice.
Right.
So list that includes those and all the other normal things that people list.
Mm-hmm.
How many of the participants are graduate students? Is it almost all undergraduates at this point?
Mm-hmm.
Well, for example, I go to site and I bring 4 other people with me, and they're all graduate students.
It started with 1 or 2 graduate students very softly with Margaret Manan's lab. And because it was popular, 2 things have happened. One is the graduate students are talking to each other, saying, hey, this is a cool thing to do. But also the PIs are no longer threatened by this getting in the way of the bench science. In fact, they do see this as a valuable experience for their graduate students. And so it's recommended, in fact, not required, there's a soft requirement from the director of the PFC that labs contribute to this activity by sending graduate students. It's never like hard enforced for the rest of it, but it's mentioned at fellows meetings, all right, these labs, everybody should contribute graduate student time to doing this. And they do. We don't, one of the structural challenges, we don't have a great way for, it's always a mad rush to get UEs, and it's always, in fact, a mad rush to get sites. Most teachers don't know whether or not they're going to be teaching at the school until weeks before, or sometimes weeks after the semester begins, and informal science is only worse if we're working with MESA, around that. But then that also determines how many UEs we want, and we do sort of this recruiting. So those are structural issues. If we create a regular institutionalized structure, I think it'll be much easier on the director, freeing up the director to do more stuff.
Another thing you might want to look at is administrators. Their, what they get out of the program.
Right.
How much they support. Science department chairs, principals, activities directors.
Right. Are they aware that this is going on? Do they value it? Good idea. All right. There is a chance, actually, that we'll be running a summer camp. We'll see. Partly it depends on REU situation and funding from NSF, of all things. But we may well be. We've been asked to run a 4 to 6 week camp at CASA. Should be fun.
We may have Rice Fellows looking for opportunities that are already, they would be funded.
Yeah. Okay. So, and then we will be actually advertising for a director of educational outreach for GILA, PFC, and joint postdoc with our group, Laurel's position, for the fall. So, this is a cornerstone, but not the exclusive list of activities that are included. So, thank you, and stay good.